Let's go through LeetCode 959 regions cut by slashes. So it gives us array of string array grid. In this kind of grid, it can be can contain character that forward slash backward slash or empty string. So it asks those kind of slashes can separate the grid to how many different pieces. So for example, example one, right? We have this kind of string and this kind of string, right? There are two strings, and this is an empty space, this is an empty space. So you see that this is connected, right? So there are two pieces. One piece is here, one piece is here. And example two, right? Because you will see it is just one part because they are all connected. So it has return one. And example three, right? So for example three, we have this one, and this one, and this one. So there are totally 5 pieces, right? 1, 2, 3, 4, 5 pieces. So what are we thinking about it? We have this kind of string character as a slash, a backwards slash in the slash, right? So if we can convert, because to handle this kind of slash, whether they are connected, it's difficult. So if we can put this kind of slash into 1 or 0, right? Then they will get our things simpler, right? So, but the thing is, let's look at the first example. If let's consider if this is 0 and this is 0, this is 0. So intuitively, we think about this is two parts, right? But this scenario is just consider these two are just all backslash, right? So if we have slash and a backwards slash, you'll see if we put this one as 1, right? This is also 1. This is also 1. So this is not correct, right? So what we think about is that if we can put these kind of ones into use some kind of one to connect. So that means if there is a slash, right? We put instead of use one cell, also we create a matrix. So instead of one cell to replace one slash, also we can separate it into multiple cells. For example, 4 cells or 9 cells, right? Or 9 cells, and we put 1, 1, 1 here, right? And 9 cells. We're thinking about for the slash, we put 1, 1, 1 here, right? So if for cell, what we're thinking about is that use this as a forward slash, use this as backward slash, right? We'll say if we convert slash into this kind of just one character into this kind of multiple cells, we don't need to handle whether that is a backward slash or slash, right? So that one we can convert this grid into a matrix which has, for example, 1, 1, 1, 1 here, right? Or 1, 1, 1, 1 here. And we just want to see how many parts which are 0, right? So that is number of islands, right? Just BFS to see how many parts we have. The one thing is that we want to mention is that separate into every slash into use 4 cells is not enough. We need to use 9 cells to represent. So why it's not enough, right? So consider this case. If we have a slash here, a slash here, and a slash here, right? So let me see. So So if we have like this, right? Like this, we need a n space. Let me see. Just why 2 multiple by 2 is not enough? Is that because if we have slash m space slash slash just this case, right? Just this case. It will separate our grid into 3 parts, right? You see, this is 1, 2, 3, right? But if we use 2 multiple by 2, so it will be 0, 1, 1, 0, right? And 1, 1, 1, 1. This is 0, right? And also 0, 0, 0, 0, 0, 0, right? So the correct answer is that it will separate our grid into 3 parts. 1, 2. Let's use a different color. 1, 2, 3, right? But the thing is that if we just use the 2 multiplied by 2, you see this one is actually connected, but it shouldn't be connected. So like this, it's not 3. It is 1, 2, 3, 4, 5. So that is not correct. But if for this kind of scenario, we use 3 multiplied by 3, it will be like a 0, 0, 0, right? 1, 1, 1. And so this will be 0, 0, 0, right? And also this will be 0, 0, 0, 1, 1, 1, and 0, 0, 0, right? And 0, 0, 1, 1, 1, 0, 0, 0, 0, 0, 0, right? So let's see. This kind of scenario, this part, this one and this one, they are not connected, right? So if we use 3 multiplied by 3, you see the answer will be 3 parts. This will be correct. But 2 and then multiple by 2 is not enough because it will mistakenly consider this one and this one is connected. So what we think about is that for every character, so we use a 3 multiple by 3 cell to represent this character. So if it is a backward slash, what we need to represent is use a 3 multiple by 3, and we have 1, 1, 1 here, the other to be 0, right? So this is a backwards slash, and for forward slash, it is like this, right? 1, 1, 1, and this is 0, 0, 0, 0, 0, right? 0, right? So this one is 1, right? In this case, it converts this our question to be number of islands. So let's write code for this question, right? So we are going to use n equals 3 multiplied by. So we know this is we are for the origin, for example, the grid is length. For every character, we need to have a 3 multiple by 3, right? So that will be 3 multiple by grid dot length. So we are going to create a matrix equals new int n multiplied by n, right? So that means that we need to look at this grid. We need to convert those kind of slash and backward slash to be ones, right? So what we do is that we iterate for int I equals to 0, I smaller than n, I plus plus, and for int j equals 0, j smaller than n, j plus plus. So we need to look at the index in the original grid, right? So what we do is that int row equals I divided by 3, right? So that is the index of this string. And let's say column equals j divided by 3, right? And we're going to use another one, right? So another index that is RR, that means in this kind of 3 multiple by 3 cell, what is the index of it, right? So it's in this cell, right? So it will be, let's use RR equals I mod 3. And CC equals J mod 3, right? So what we do is that if grid R of char at C equals backward slash and if it is backward slash, right? So which one we need to be 1, right? We need a RR plus in this 3 multiplied by 3, right? Which is RR plus CC equals 2, right? Equals to 2, and RR plus CC equals to 2. If this kind of case, that we are going to set this matrix ij equals to 1, right? This is for the backward condition. And we'll say or just slash grid R dot char at C equals slash, right? And RR equals to CC. In these two kind of cases, we want to set a matrix ij equals 1, right? So our question will become number of element. We're going to have int result equals to 0. So we're going to have q int q equals new array. Yeah, we can use a weighted hasset, but since that this matrix is not the one with as a parameter we pass in, so we can change the matrix after we weighted, right? Change this to 1 or 2, right? So this will not affect the one we pass in as parameter. So originally, that means that it's good behavior that we do not change the reference passing as a parameter, right? We don't want to change this grid, but this matrix is what we generate. So it's fine that we set the v to 1 as 2, right? So what we do is that for int I equals 0, I smaller than n, I plus plus, and for int j equals to 0, j smaller than n, j plus plus. So what we do is that we're going to have q offer new int I j, and we're going to set a matrix I j. We can set this one as 1 or 2, right? Whatever. And set as let's set as 2, right? And say while this queue is not empty, and we're going to use it into current equals q dot pull. And so what do we do is that we need a direction array private final static int b row equals 1 0 minus 1 0 and also the column equals 0 1 0 minus 1. Okay. So what we do is that for the 4 directions, for int k equals 0, k is smaller than 4, k plus plus, right? So we're going to have int new row equals current 0 plus row k, and int new column equals current 1 plus column k, right? So we need to find the boundary, right? If new row smaller than 0 or new row greater equal to n, or new column smaller than 0 or new column greater equal to n, or matrix new row new column doesn't equal to 0, we need to continue, right? Continue. Otherwise, we need to enqueue, right? Before we enqueue, we can set this matrix new row, new column equals 1 or 2, whatever, right? To offer new int, new row, new column, right? So this is mark the island. What do we do is that for every the next time if we mark our island as 2, right? Next time we see another 0, that means there is another island, right? So what we do is that we need a count, right? So after this while we have result should increase by 1. In the end, we return result. So this is using BFS. We should be outside, right? So this one should be outside. Let's look at what's our problem. So the thing is that we need to check whether this matrix equals to 0, right? So we'll say if matrix I j doesn't equal to 0, we should continue, right? We can only put this one equals 0 to in our done equal to 0, then continue, then offer. Okay, offer this one. While this one goes for Taiwan plus T column. Then we offer a new row result plus plus. So it is why is it 6 6? So if matrix IT done equal to So, and pull K. So 3 multiplied by grid mod. This looks correct. And the result, original result, smaller than nj, smaller than n. So we only when that is 0, we're going to offer. Then we offer this kind of ij and set this to be 2, right? In the 4 directions. If smaller than 0 or greater equal to 0, or this one done equal to 0, we need to continue. And set this one as 2. And offer new row, new column, result plus plus. This should be here. It should be result for each, but still doesn't explain this is yeah. So that is we are let's sum it. The time complexity will be for example n, right, n squared, right, in a space that is also n squared. So the length, right, so it will multiply by 3 to be n, right? So and we can convert this to be Python code, write this one as Python as well, right? So we need 0 equals, for example, 1, 0, minus 1, 0, right? And we need a b column equals 0, 1, 0, minus 1. Okay. So we are going to have n equals 3 multiplied by length grid. And then we are going to have a matrix. Matrix equals this one multiplied by n for this one in range. Okay. And we are going to say for I in range n, for j in range n, right? Then what we do is that we are going to have r column column, right, equals so this will be I slash 3, right, and j slash 3, and I mod 3, and j mod 3. Okay, so what it is that if grid r column, right, equals forward slash and RR plus CC equals R equals 2, right? And say or grid R column equals slash, right? And RR equal to CC. Then we're going to have a matrix I J equals 1, right? So we compose a big matrix. So we're going to have result equals 0, and we're going to have Q equals D deck, right? Then we're going to have for I in range n, for J in range n, right? So what we do is that if matrix I J equals 0, then we're going to in Q, right? So we're going to Q dot append append ppend append ij, okay, and the matrix ij. Let's set this one as true, okay. And we're going to, let's say, while this queue is not empty, right? Q, I think you have current equals q dot top left. Then for k in range 4, right? Then we're going to have the 4 directions. Let's say new row equals current 0 plus self dot d row for k, right? And the new column equals current 1 plus self dot d column, okay, right? So we need to see if new row smaller than 0, right? Or new row greater equal to n, or new column smaller than 0, or new column greater equal to n, or matrix new row new column doesn't equal to 0, right? Then we need to continue. Otherwise, what we do is that we need to matrix new row new column equals to, and also we need to have q append new row new column, and if this one equals to 0, right? So we should be here, right? So we should have result as equal to 1, and in the end we just return result.